All right, so this is 5.3, but really what you're going to find is everything that we're doing in 5.3 we just did in 5.2. So what we're doing here is we're solving exponential equations. So what we want to do, so the goal here is to get the same base on both sides of the equation. So we want the same base on both sides. So how do we do that? We're going to change the base so that they're equal. And then we're going to set the exponents equal to each other. Now, sometimes we're going to have to make changes on both sides. So change the base on one or both sides of the equation. Okay, so this is a perfect example of this. So I have a base of 8 and a base of 4. So I can't turn this 4 into an 8 because if I do this as 4 squared, that's going to be 16. So what I want to do is I want to convert all of this to base of 2 because I know that I can double and triple to get where I need to be. So what this looks like here is 2 to the negative 3, right? So the 8's in the denominator. To get it in the numerator, I have to make it negative. And it's 2 cubed, that gives me 8. Now I have this exponent, so I have to keep this exponent. So I'm going to keep this x plus 1 exponent there. Okay? Now, again, the goal is to get same base, so I'm going to make this 2 squared. 2 squared is 4. All right, so now what you see is that I have the same base of 2 and the same base of 2, so I'm going to set my exponents equal to each other. So I have negative 3 x plus 1 equals 2. So I'm using this exponent right here equals this exponent. And now I'm just going to solve this. So I could distribute this, but I'm not going to. I'm just going to say x plus 1 equals negative 2/3. If I divide this by 3, divide this by negative 3, this is what I get. I move the 1 over, so I have x equals negative 1 minus 2/3, right? So minus 1 on both sides. So this negative 1 is the same as negative 3 over 3. Because these are fractions, I have to have common denominator to add those up. So negative 3 minus 2 is going to be negative 5/3. And that's my solution. So what this is saying is if I take negative 5/3 and I plug it in here, I'm going to get 4. And I know it's like, wow, how does that happen? Well, let's just look at this on a calculator real quick. So if I look at this on a calculator, I would have, I'm going to use parentheses, I'm going to put 1/8 in here. And now I'm going to put this to the negative, I'm going to use this as a fraction again just so that we can see it, right? So 1/8 to the negative 5/3 power plus 1, because I'm going to plug this in for x plus 1, and when we plug that in, we get the value of 4. So it works. I know it looks funky, but it works, okay? All right, so we look at this next one. So this next one, I have 27 and I have 9. But I cannot just say times 3 because what we're doing here is we're trying to find multiples that are going to give me 27. So if I convert this to a base of 3, I would have 3 cubed. 3 times 3 is 9, times 3 is 27. And I leave my exponent up here, x minus 4. On this side, I would have 3 to the negative 2. 3 to the negative 2 gives me 1 over 9. Remember, negative just tells you it's in the denominator. And now I have 2x plus 1. I have to leave that exponent up there. Okay? So this is what I wanted. I have same base. They both have a base of 3. So now I'm just going to set my exponents equal to each other. So I'm going to do the math as I go. So 3x minus 12 equals negative 4x minus 2. Okay, so if I move this over, I would have 7x equals, I move this over, 10. So this tells me that x equals 10 over 7. Again, it's a number that's not pretty, but we can plug this in to both sides of the equation and see that it works. All right. Now, this next one looks hard, but here's what I have. So if I see 3 over 4, I have 16 over 9. So if I took this value and I squared the whole thing, I would have 9, and I square this, and I would have 16. So what I have right now is I have this that's flipped. So this is flipped, and what I want is 9 over 16. So if I have this 9 over 16 and I flip it, I know that I'm going to have a negative exponent. All right, so right away I have this negative exponent. But I also know that what I want to do is I want to have half of this value that's on here. So my left side becomes 3 over 4 to the x plus 2. And my right side is also going to be 3 over 4. But now I'm going to square it. But I know that it has to be negative. So I'm not going to make it squared. I'm going to make it a negative 2. So if I square this, I get 9. I get 16. The negative tells me that it flips. And then I still have 3 minus x. So now I have same base. So if I solve this, I would have x plus 2 equals negative 6 plus 2x. So I just distributed as I wrote this out. So if I solve this, this gives me 8 equals x. And that's my solution there. Okay, so the key here when we're solving these exponential equations is we want to have the same base. We kind of did this the other day, it's just that they're getting harder. Okay, so now we're going to look at this a different way. We're going to look at the different base method. All right, so if I go back over here, every one of these problems that I was able to do, I was able to get the same base. But sometimes you can't get the same base. So here's how we're going to solve this. So different same base, which means we can't simplify to the same base. So step 1 is we're going to isolate our exponential term. So we want our e to the x to be all by itself. Okay? The second thing we're going to do is change this to log form. That's what we did in section 5.2 is we converted back and forth between exponential and log, and then the last step is solve for x. All right. So here we go. Let's look at this first one. So I have e to the x plus 1. So what I have here is I have, this is already isolated. I know that we have this x plus 1, but there's nothing else here. It's just e. So this is isolated. So step 1 is done. So the next thing I have to do is convert this to log form. So if I have this, I'm going to say my base of e, so ln, and then that base is my exponent. E is going to be my answer equals x plus 1. So if I look at this, this becomes my base. So my base is my ln, my answer's here, and this equals my exponent. All right, so this was step 2. And then step 3 is solve for x. So I'm just going to subtract this 1. So I'm going to end up with x equals ln of 4 over 5 minus 1. And that is my solution. So this is not always something that we can simplify. Not always simplifiable. We can't always simplify. Okay, so we're going to try this one. So with this one, first thing I want to do is isolate. So if I'm going to isolate, I'm going to add 10 to both sides. Now I'm going to divide by 2. And now what I can do is I can put this in my log form. So here I have log base 5 equals 7, or sorry, log base 5 of 7 equals 3x. All right, so now I've got it in log form, and now I solve for x, so I'm just going to divide both sides by 3, and I get log base 5 of 7 over 3. And that's my final answer. Okay, last one. So this is odd. I have a base here and a base here. So what I'm going to do is I'm going to do the same thing, and I'm going to popcorn this guy out. So I would have log base 7. of 3 to the 2x equals x minus 3. Okay, let's go through this again. So here's my base 7. So equals the answer, equals the exponent. All right, so now I'm going to use my log rule, and I'm going to pull this 2x out front. So what I have is 2x log base 7 of 3 equals x minus 3. Okay? All right, so next step here. Next step is I have an x on this side and I have an x on this side. So because my last step is to solve for x, I need all my x's on the same side. So instead of moving the negative 3, I'm actually going to move the x. So here's what this looks like. 2x log base 7 of 3 minus x equals negative 3. And I know this looks super confusing, but the reason we did this is so we would have a GCF. I'm going to pull out this x and I'm going to pull out this x. So I'm going to factor out an x. And when I do that, I'm left with 2 log base 7 of 3 minus 1. So I factor out the x here. I factor out the x here. And this is going to equal negative 3. Okay, so my last step is to solve for x. And all I'm going to do is divide by this whole term. And I know that looks like a really awful answer, but that's it. That's our answer. So this one is about as tricky as it gets. You've got one like this on your homework that's a little challenging. And so make sure that you come back and review this one before you do the homework. Okay, thanks. That was it. It's a fast one.